statistical topic. And this time around, we want to focus on what I call repeated measures. Now, the outline today, like today's topic, just going to be an introduction. Now, in today's, you're going to learn basic concepts of repeated measure. We're also going to talk about longitudinal and cross-sectional analysis. And of course, there's going to be our example. Now, I'm going to start with what is a repeated measure. Let me just first tell you this. So the type of data that we use in repeated measure is a longitudinal data. But before I go into this title, I think I would like to have a recap on what we've done before so that we'll be able to retrace our step, okay, back to this topic. There is nothing that we cannot undertake with statistical approach. I'm going to say that again. Whenever there's a problem in a stochastic environment, don't forget I told you the other time, we live in a probability space because there's a lot of variations around. And because of that, we normally want to compare things. And if there's no variations, there's no way we're going to be thinking of comparing. Okay? So now that we want to compare things, I remember when I started this course, I was reviewing conventional statistics like one sample t-test, two sample t-tests, all the way to analysis of variance to ANOVA. Now, let me tell you this. I can start, if I want to start my comparison, do you know my comparison can start from one group? How? What am I comparing in one group? Maybe somebody make a claim. Probably, maybe the person said the annual average income in the United States. Maybe the person says 40,000. And I'm going to say, okay, I want to investigate that because following every claim, we'll normally want to have an investigation. Now, what do I want to compare? I basically want to compare sample mean with the population mean in that regard because the claim of that person becomes an hypothesized value for me, which is a population mean. And when I investigate it, I'm basically going to get a sample, right? I get a sample mean. What am I testing? I basically want to test if there's equality or if there's no significant difference between the sample mean and the hypothesized value. That's a comparison in one group. When I go to two groups, this time around, if the two groups are independent, then I'm basically going to use a two sample t-test, provided if assumptions hold. Okay? And if the two groups are dependent, I'm going to say that again. If the two groups are dependent, then I'm basically going to use a paired t-test that we also call a dependent test. That is when two groups are dependent. Okay. Now, in a situation where I'm no longer comparing two groups, but I'm, want to compare more than two independent groups, the analysis of variance comes in. You can see this story. The analysis of variance comes in. You may be considering one-factor experiment, it may be two-factor experiment, it may be three-factor experiment, it could be factorial experiment with interaction. Now, let me just tell you, all what we've done before now, we are assuming independent groups. I'm going to say that again. All what we've been doing before now, we are assuming independent groups. But if you look at one of what we've done before, there is one that we call a PRT test, right? A PRT test is, I'm having two groups, but it depends. But what if in a situation where I got more than two groups? That depends. I'm going to say that again. When we have two groups that actually depend, okay, we use a paired t-test. What if in a situation where we got two groups, or where we got more than two groups, and they depend? Of course, we cannot use sample t-test. We cannot use analysis of variance test. Because the analysis, one of the assumptions of the analysis of variance is the independence of the groups. And I want to tell you now, situation where we actually want to compare more than two groups and they depend, then we are talking about repeated ANOVA method, which is today's topic. You can see the story now. Statistical story. It's like a movie. You shouldn't miss out. Just like you go to a cinema to watch a movie. Maybe along the lines, you add a call. By the time you come back to the movie, you may not be able to understand the movie anymore. If it's a good movie, you may not be able to predict because you've already, lost some scenes. So that is the way statistical stories are arranged. They are arranged in a way they are connected. Now, like what I'm presenting today, I got more than two dependent groups. I can no longer use a PRT test. And I'm actually going to use ANOVA with a repeated measures. Does that make sense? So which means what we want to do today is a generalization of a PRT test. The PRT test is only be used when the groups are, you've got only two groups that are depending, but you have more than that. Basically going to use this guy. And that was why if you take a look at, it means the data we're going to be using is going to be a longitudinal one. What do I mean by that? Okay, it means I'm actually going to be collecting data from the same subject at different occasions. I'm going to say that again. I'm going to be collecting data from the same subject at different occasions. The occasion is going to be more than two. If the occasion is just two, of course, I'm actually going to go with a PRT test. If the occasion is more than two, I'm actually going to go with this topic. So the longitudinal data, that is what it means. So that's why you see, individuals, experimental unit, etc., they are being measured multiple times. Okay, that is why we call it ANOVA with a repeated measures. Okay, and this actually, it allows us to investigate the treatment effect on the response over time. We basically want to see, some people used to say, data do expire. I remember following up to 2016 general election, the presidential election in the United States. I was still in Africa as at that time. A lot of results that I see conducted by pollster actually gave that election to the Democratic candidate, Hillary Clinton, as at that time. None of the poll actually suggested that Trump was going to win the election in 2016. What has happened? Does that mean data expire? And that is the reason why at times when you come to me, when you go to an individual to collect data at one time, I think it's better to go to do a follow-up because things can change. So, so that is what we mean, this is being used in clinical trials. I remember when the Pfizer, Moderna, and the like, when they claim to have efficacy for COVID-19 vaccine. I remember people receive first dose. The same people that receive first dose also receive second dose. That's a repeated trial. And even third dose, someone like that, booster, is the same person, Take a look at that. And they notice that the effectiveness of their vaccine changes because, Pfizer arrived at 95% efficacy rate. I want to believe Pfizer did not say it is their first dose will not give 95%. It is only at their second dose. So we basically want to study how does the response variable changes over time. Then if you want to do that, then you use, if you have more than 2 dependent groups, then you're basically going to consider this topic. Okay, so I said up to now, we deal with a single measurement taken at one point in time. One point in time, the one we were doing before now. They were all and that's why those observations are, independent. Independent in the sense that we did not visit any subject or experimental unit in more than one occasion. Okay, now it means what we were using before, we called that a cross-sectional study. That was a cross-sectional study. Okay, so I'm just trying to use, to see the difference between a cross-sectional study and a longitudinal study. So it means the one we were talking about before was a cross-sectional, cross-sectional. We go from one individual to the other. But this time around, we're visiting individual in more than one occasion. Okay, and I said when each subject give rise to a vector of different response measurement, then that is going to be called motivated analysis. A single subject giving different responses, probably giving different responses at different occasions. I'm actually going to walk you through an example from biostatistics this morning on this. Okay, and I said when each subject give rise to a vector of the same response, okay, then we use a repeated measure or longitudinal analysis. Okay, and let me tell you this. When we are talking about repeated measure ANOVA, you cannot use the conventional approach of ANOVA. Why? Because of the fact that the response from the subject are not independent. I'm going to say that again. There's a violation of independence. Don't forget, you are taking data from the same subject at different occasions. And that was why I said, because we are measuring the same person or experimental unit, then the observations should be correlated. And when observations are correlated, then it means there's a violation of independent assumption. Okay? So that's a violation of independent assumption. And most of statistical tests that assume assumptions of independence cannot be used here. That's what we mean. Therefore, we need a brand new statistical approach that will take into the consideration the correlation. Does that make sense? So that is exactly. Now, what are the kind of questions that we basically want to ask using repeated measures ANOVA? Number one, how does the response change over time? I think I just mentioned COVID-19 vaccine. When you get the first dose, I think the second dose was it after 2 or 3 weeks? Okay. Now, does the response variable in that regard that I'm going to say is, I think the ability not to catch a COVID or ability not to fall sick when a vaccinated individual get exposed to COVID. But what we're trying to say now, the efficacy of the vaccine now is the response variable here. So which means the efficacy of the vaccine when you get a first dose, we want to compare the efficacy of that vaccine when you get the second dose, when you continue to go, maybe third dose, booster, and so on like that. And that's what we mean. How does the response change over time? Then two, how does the treatment affect the response? The treatment in that regard is just going to be the first dose. What is the effect of first dose? What is the effect of, does the effect of first dose have the same as the effect of second dose and so on like that? Does the response change differently over time for each treatment? If so, how? You know, I'm going to give my own example before I go to the example that I gave in this lecture slide. Because the way I understand my statistics is when I give, I will always have, when I learn statistical concepts or mathematical concepts, I'm only going to tell myself, I understand that if I'm able to cite my own example. I want to cite my own example now. I want to take you into medical field. Okay, now I want to go into a medical field right now. And probably we got some patient in our hospital. Let us assume now we are in a clinic now. We are in a clinic now. And some patient actually need our attention. Okay, now let's assume that let me first confirm those of you online. Can you all see the board? Those of you watching online, I need someone to talk. Can you all see the board? Because I want to write something on the board now. I need someone to, okay, thank you so much. And those of you online, you can also ask questions by talking, okay? You can also ask questions by talking as well. Now, I want to give an example now. I want to start with one factor ANOVA with a repeated measure. Okay. Does the person, if you are not seeing what I'm writing, those of you online, please let me know. One factor ANOVA, okay, with a repeated measure. You know, right now, I'm going to give an example of one way, a one-factor experiment. One-factor experiment is written as one way ANOVA with a repeated measure. I'm going to give you an example now. We got some patient in our clinic. Okay, and this patient in our clinic, they got new injury. Okay, they play sports. They play basketball. And because of that, they got new injury. Okay, now what we want to do is we are actually want to treat them. Maybe they're going to undergo what I call a surgical operation. Now, there's something that we basically want to test. We want to look at the perception of pain. Perception of pain of the respondents. I'm going to write it here. Perception of pain. Perception of pain. Okay. Now, this is what I want to do. I'm actually going to have 3 different time points. The very first time point is before surgery. Okay. In the middle of the surgery and after surgery. If before surgery, I'm actually going to observe the perception of pain on the patient in the middle of the surgery. The same patient, you know, if I have 20, if I have 20 patients, okay, each of them, I will visit them in 3 occasions. Before the surgical operation, I'm going to ask them about the perception of pain in the middle and after surgery. Okay, so where am I? What do I want to do now? I basically want to compare their perception at different time, and this time form groups. But these very groups, they are dependent. Does that make sense? We don't have an independent groups here. This group, they are dependent. So which means the one factor that we're talking about is time here. Any question? One factor that we're talking about is just time. Any question? So which means the difference between this and the one-way ANOVA that we did before without a repetition is that we are not collecting, time is not a factor. Time was not a factor. We did not collect observation from participants at different occasions. We only did that once. That was in the one we did before. But this one now, we observe the patient in more than 2 periods. Any question? That's what we call one-factor analysis of variance with repetition. Now, I'm going to give an example of two-factor now. How do, in analysis of variance, we got two-factor ANOVA, right? Oh, factor A, factor B. We can also have, with the interaction, the one we've done before, okay, is not a repeated. The participant or the subject was not visited more than one time. But this time around, I'm going to give you an example of two-factor analysis of variance, okay, with a repeated measure. Any question on this before I move to that one? Any question? Make sure you give your own example. Okay? Make sure you give your own example. If you give your own example, you're basically going to be fine. Now, this time around, I want to consider two-factor now, or two-factor experiment, or let me just say two-factor ANOVA, two-factor ANOVA with a repeated measure. Let's say we're seeing clinic. Let's say we get some patients that have high blood pressure. Okay, maybe some of them are hypertensive. And you are now trying to test the effect of a therapy. Okay, your response variable is blood pressure, right? And you want to factor A. Let me tell you, when you are using a repeated measure, automatically time is going to be one of the factors. I'm going to say that again. When you are using when you are studying repeated ANOVA measure, ANOVA measure which are repeated. Now, the time, the first factor is a time. Factor A is time. Don't forget, you're basically going to visit your subject in more than one occasion. You know that? Let's say factor B now is the therapy type. Therapy type, right? Maybe the therapy here, maybe you got three of them. Okay? So what do you want to do here? You basically want to compare the blood pressure at different time. You want to see whether blood pressure changes from time to time. That is number one, which means you are testing the effect of factor A. Okay? And that is what you see on the board. How does the response change over time? How does the blood pressure of my patient changes over time? Because as a doctor, I'm going to measure their blood pressure over time to see if there's going to be any improvement. Not only that, the second factor is the therapy type. Maybe we're using different therapy. We also want to know whether there's a significant difference in the therapy use. Do you know we can also look at the effect of interaction? I told you in statistical analysis, when you talk about interaction, when interaction is significant, you know what that means? If the interaction of A and B is significant, then it means A is not consistent. When you put into consideration different levels of factor B, because if A is consistent, putting into consideration different levels of factor B, then the interaction should not be significant. I'm going to say again, interaction is not needed in a model where the a particular factor maintain consistency, putting into consideration the levels of the other factor. But what makes interaction to be significant is when a particular factor is not consistent. When you try that across the levels of the other factor. Now, let me go to what I used in the lecture slide. This is my own example. Now, the example I used in the lecture slide, we're going into education now. Oh my God, I love this example where, students are recruited when they were in 6th grade. And we follow them until 12th grade. Oh my God, the same students. Unfortunately, there's going to be a dropout. I could remember we were in one district before, and I relocated with my family to another district. Imagine if one of my children is in the cohorts for their study, what has happened? Drop out, because that means my child is no longer in that school district because we relocated. That's going to be one of the disadvantages of a repeated measure ANOVA. Okay, so the students that were in the study were assessed when they were in 6th grade, 9th grade, and 12th grade. That make it a repeated measure ANOVA. If they were only measured at 2 different time periods, that would still be a sample t-test. Well, that would be a paired t-test. But right now, the occasions is more than 2. And that's what we're talking about. The issue of the longitudinal study will come in. Okay? And of course, we can now ask a question. How will you design a study to assess whether a 12th grade teacher are better than 6th grade or 9th grade teachers? When I'm teaching, I started my teaching career when I left high school. In fact, when I was in high school, I was teaching the elementary students. Oh my God, elementary students are very difficult to teach. Adults are matured. I remember when I was teaching that I have to be running around. Oh, sit down there. Oh, sit down there. Now, we're not talking about the level of qualification now, but we're talking about the impact. Because we could have an elementary teachers that are even more impacted than a college professor. Now the question now, how can we design a study to assess whether the 12th grade teachers are better than the 6th or 9th grade teachers? But before we can do this, of course, you can see you have to recruit students into your cohort. When they were in 6th grade, you observe that again in 9th grade, you observe them again in 12th grade. Now we got for the longitudinal, student performance, where we are actually plotting the score against the grading school. Okay, don't forget, we're talking about, if you go back, I explained here, look at what I call longitudinal. When you follow the same students for 3 grades, don't forget, 6th grade, 9th grade, 12th grade. Does that make sense now? That's what we call longitudinal. But what about a cross-sectional? When you select different students from the 3 grade on a single location, that's a cross-sectional. And of course, in the cross-sectional, you expect the responses to be independent. But in a longitudinal, where you visited the same student in more than one occasion, then you don't expect the response to be independent. You expect the response to be correlated. That's what we mean. Okay, so that is what that guy is showing. Now, longitudinal versus cross-sectional analysis. What is the pros of the longitudinal studies? Of course, I said in longitudinal study, we can assess changes over time within individuals. We live in a stochastic world. Okay, our thinking, okay, changes over time. So a politician can come to me today and say, okay, who do you want to vote for? And I say, okay, I'm going to vote for this guy. And maybe before election, they can come to me again and say, Do you still want to vote for that guy? Because I know a lot of things might have happened. So I expect them to display their manifestos, or maybe along the line, and they said this guy had some scandal. I can say, okay, because of the new development, I'm no longer voting for this guy. And somebody can say, I'm still going to vote for this guy. Does that make sense? Okay, now, in some discipline, it is a good science to study individual over time and look at the response over time. Okay? It's a very good thing to do. Now, and also notice the variability within a student is most likely to be less than between. Because, it's the same person. The variability within will be less than when you talk about across student. That's what we mean. Okay, now what is the cons? The issue we have with a repeated measure. So it's basically going to take more time. Imagine you started following students when they were in 6th grade up to 12th grade. Oh my God, that's a lot of years. Okay? As opposed to what you normally do before, that you just assess them on just one time. And I say a longitudinal study is more difficult to conduct, to get everyone measured at the appropriate time, and to keep people from dropping out. So are you going to tell me because you are using my daughter for research, if I want to relocate, I shouldn't relocate? You can't tell me that. Okay? And the analysis is more difficult, but I can assure you we have a software that can actually tackle that, no matter how difficult it is. Okay? Now, there is one example that I want us to walk through, which I'm basically going to call data example. Here we want to look at the distance, okay, from the center of the pituitary gland, okay, to the, pterygo maxillary tissue or tissue. So as you can see, we want to look at the distance because scientists believe the distance changes over time. Maybe the distance between these two, it changes over time, and we may want to see that. Okay, this is what I'm trying to say. Because why are we interested in that distance? Because that plays a role in the growth of it and the reproduction. That's why we're interested in that. This is biostatistics now. Oh my God, statistics is very, very interesting. Take a look at that. Begin to look. When you look at hospital, it's not only doctors that work in hospital. Statisticians are there to guide doctors statistically. Okay, I'm going to say the world cannot survive without statisticians. Oh, let me put it this way. The world cannot survive without statisticians or without statistical knowledge. And that's why you are here to acquire statistical knowledge. Okay, now on this study now, on the dental data that we're talking about, where we're looking at the distance between two variables, they enroll 27 children, 16 males and 11 females. And for each child, the distance from the center, okay, of the pituitary gland to the, pterygo maxillary tissue measured on each child when the child was 8 years, 10, 12, 14 years of age. Oh my God. How many time period? 4 time period. But when you want to look at the years from age 8 to 14, that should be 6 years, right? If you take a look at that, but at different, different time period. And because of that, we're having a repeated measure over here. Okay, the response variable is going to be distance, and that should be continuous. And what was the question? Does the distance change over time? Over time means, at the age of the distance for one person now, for this particular person, okay, at age 8, is the distance statistically different from when this guy now grow to age 10, to age 12, to age 14. Does that make sense? then what is the pattern of change? If there's a change, the pattern of change becomes more important to us. There is a pattern different for males and females. Don't forget. That's another factor. When you take a look at what I see here, this is a two-way ANOVA with a repeated measure. Where I can see gender and I'm also seeing time. Don't forget, I told you when you're working with a repeated measure, the repeated measure automatically, generate factor A. The factor A is going to be time. Or you can call it age, year, time and age. Then the factor B is basically going to be gender because you got male and female. Okay? Take a look at this. I'm having a measurement for girls here over time, plotting the distance against their age. Okay? Take a look at this. This is for the boys over time against their age. This is between male and female over time. We talk about the distance, when you plot the distance against the age, okay, for male and female over time, you can see a line. For male, you can see a line. For female over time, because we also want to see whether there's a difference between male and female when it comes to the distance that we talk about over time. Now, like I said, the data here are balanced. Okay, let me come again, and I'm going to come again now. You remember when we're dealing with without repeated measure, we have balanced and unbalanced data, right? Okay, in unbalanced data, we make use of type 2 sum of square, type 3 sum of square, and the like. Okay, now we also have the same here. But in this data, because the children were observed, okay, at equal number of time points, that's basically going to be balanced. Does that make sense now, right? And as you can see, I said for most individuals, the growth can roughly be described. This is more or less like interpreting what you see here. Okay. Okay. Now, this is another study. The Cebu Longitudinal Health and Nutrition Survey recruited pregnant women in 1983 and 1984 in the Cebu province of the Philippines. And, anthropometric measures of the children were taken at birth and every 2 months until the age of 2. That's a repeated measure. Okay? A major interest of investigator was growth restriction, as given by UNICEF. Report that even now 20% of Filipino children have stunted growth. Okay? And more stunting is due to maternal and child malnutrition. Okay? Now, the question here is, what factors, if any, can we use to predict child growth? Then is there homogeneity across children on growth rate? Okay? That's actually need to be answered. And we can actually achieve that within the framework of repeated measure. Okay, now this is the graph for the weight. Now, there's another study. There's a lot of study, here. Okay, there's another one. A transgenic mouse biopsy was conducted to study the effect of dioxin exposure on papilloma, a type of skin tumor. Okay, papilloma. You're going to see, I'm going to show you a picture now. Development in mice. One of the most toxic chemical nodes has been linked to decrease fertility, increased risk of birth defects, and increased risk of cancer in humans. Mice were assigned to a single dose. Why are they using mice? Because when you look at the physiological structure of man and mice, the difference is not it's not statistically significant. When I talk about physiological, I'm not talking about anatomical. Anatomical is talking about the organs in the body, but physiology talk about the functioning of the organs, why do we use mice, in an experiment that has to do with human beings? Because there's no significant difference between the physiological difference, or the physiologic, the way the body of the mice and the human function. That is the reason. Now, mice were assigned to a single dose of one of the following 9 doses and followed for 26 weeks. Followed for 26 weeks. Then we're talking about repeated measure. And the number of skin papillomas recorded weekly. Then the skin papilloma may disappear so that the number of tumors may decrease. There's another example. Take a look at this person here. Okay. You see people changes over time, right? This is one of the reasons. Take a look at that. This is a tragic effect of dioxin exposure. Okay. So take a look at that. Now, the summary of the terminology. Today we've used individual. Individuals are called the subject. They are the experimental unit. And of course, they are the participant in a longitudinal study. We refer to them as patients in hospital. We refer to them as students in educational line. Okay? Then occasion means, different period, different time, different position. Okay? And of course, when the number and the timing of the repeated measurement are the same for all individuals, then we are talking about balance. Because we could have situations where they are not the same. Some individuals, but that would be a difficult one because with the situation we want is, okay, let's have a way to study. But the reason why we normally have unbalance at times, maybe that we have drop out that we cannot rule out. Research are very expensive. We're limited by budget. Don't forget that. Okay, now let's talk about the features of the longitudinal data. Let me tell you this. We're starting from the response variable. The response variable in a longitudinal data can be continuous, can be binary, can be counts. Let me tell you this. For you to use a linear regression, right? Your response variable has to be continuous. When your response variable is binary, you can no longer use linear regression, but a logistic regression. But what if in a situation where your response variable is a count, you got a count data, then we're going to be talking about Poisson regression. Does that make sense? So which means when you are talking about longitudinal data, the response variable can be continuous, can be binary, can be counts. And of course, we have subjects. I'll quickly go to the data here because of my time. I want to show you the data formats. The way we present the data formats. We normally project that in 2 forms, wide or long. Take a look at the wide. I'm showing you the first 6. The wide, okay, you're going to have the subject, the gender, then you're going to have age at 10, age at 8, age at 10, age at 12, age at 14. Take a look at that. Subject number 1 is a female at the age of 8, right? That's what we measure. That distance that we talk about is 21. At the age of 10 is 20. At the age of 12 is 21.5. From the same individual, we are getting different responses. This is when we project that in a wide. In a long, you know what we do in a long? We normally have we group the data by time. The first set of data is, you can see time 8, 8, 8. We're also going to have time 10, 10, 10, and so on like that. Take a look at that. Now, I'm going to show you the analysis. The conventional approach that we call naive approach that we use, when you want to look at the effects of age and gender on distance, the conventional approach is to run a separate linear regression. What is this result telling me? Oh, I'm going to run four tests, right? Which means I'm going to consider age 8, age 10, age whatever. This is a naive way of doing it. This will not enable us to know the changes over time. This one will only tell us what happened within a particular time. Those are missing. Here you're only looking at the effect of, that's why age, take a look at age here is continuous, because you're looking at it, one at a time. Okay, this is when there's no interaction, and this is where there is interaction. This is just one of the 4 results, but this is using a naive method. But when else we're going to meet, I'm going to show you the standard method that will enable us to investigate everything at a time, simultaneously. Any question before I go? Okay. Make sure you stay safe and have a lovely day. Bye for now, everyone.